Friends, architects, student of architectural engineering, consultants, and students of physics. Once again into VK Jan Sarki MEP classes. In this particular module, I am going to discuss the theory of illumination. First, I will discuss the color theory. Previously in architectural engineering, the basic colors were taken as RYB, red, yellow and blue. But uh, for computer screen, we use additive type color combinations, and for printing purposes, we use subtractive type color choices. Now this one is RGB, whatever we see on computer screens and any other monitor like this, uh, we get R red, G green and blue. And when we add all these color, we get the white effect. As compared to this, we have a system of subtractive color system, which is mostly used in case of paint. And the sum total here it is CMYK. C for cyan, M for magenta, yellow, Y, Y for yellow, and K for black. So this is known as CMYK system. CMYK system is subtractive and is pigment based. Friends, this is about primary, secondary and tertiary colors. Let us start from the primary information. Basic colors, also known as primary colors, are fundamental colors that cannot be created by mixing other colors. The most common set of primary colors in traditional color theory was RYB, red, yellow and blue, which are used by artists to mix all the colors. In contrast, in additive color mixing of light like this, the primary colors take uh, are in the form of red, green and blue. This is what happens in computer screens and monitors. There are three different models for primary color. Any of a set of colors that can be used to mix a wide range of hues. There are three common used primary color models: RYB traditional, RGB computer based, and CMYK is दादू हाँ बड़ा वाला पैकेट मंगवाना है छोटा वाला CMYK. The color variation among the models are due to differences between additive and subtractive color mixing. There are also definitions of color based on color wheel. We begin with a three-part color wheel. The color wheel using primary colors, the color wheel using secondary colors, and the color wheel using tertiary color. Friends, there is one more color system which is known as Muncell color system. This is primarily used for furniture and such items, selecting color for furniture and other such items. The Muncell color system is a means of visually identifying and matching color using a scientific approach. Albert Muncell was both a scientific thinker and an artist who wanted artists and scientists to have a system that made it easy to express color in a concrete way. A soil scientist accurately addressing the makeup of the soil in the field. An artist in the studio replicating colors when mixing paints and materials. And quality control experts making sure final product colors match the set standard. These are the three applications of Muncell color system. The Muncell color system describes any color using three attributes of color. Hue. Five principal hues are red, yellow, green, blue, and P. And five intermediate hues are YR, GY, BG, PV, and RP. Value. Lightness or darkness. Scale ranges from 0 pure black to 10 pure white. And chroma. Chroma describes saturation or purity of the color, measured from the neutral grays at center. Could be divided minimum 8 to 16. Now this Muncell color system has got X, X and Y scale. This is X scale having 8 values, and this is Y scale having 9, 10 values like this. And these are the various colors which can be selected as per Muncell system. This is the Muncell color system. Once again, uh, on x-axis we use chroma, and on y-axis we use values. We are discussing now lighting system as per CIE classification of general indoor lighting luminaire. This table has got 4 columns. First one is type of system, and second and third are the component of downward or upward light in percentage, and the fourth column is relative horizontal spacing. This is very clear here. We we have given two type of system here: shaded or reflector system, the fittings which are having reflector, and diffuse system where there is no reflector, but there is a at bottom perspex cover. There is a cover. The reflector system gets classified as per direct, semi-direct, semi-indirect, and indirect. And these are the percentage of light which they try to put forward, either downward or upward. And this gives you relative horizontal spacing less than 1.5 of D, where D is the depth of working plane from luminaire or ceiling or false ceiling. Dear friends, now we are discussing over the phenomena of reflection. Reflection, the most common form of controlling light, occurs when light rays impact and are then reflected from a surface. The types of reflection include specular, second diffuse, third spread, fourth selective. We'll define all these one by one. Specular reflection is when light is reflected from a highly polished surface such as smooth polished metal producing a consistent angle. Second, diffuse reflection is what the light is reflected from a rough surface producing a variety of angles depending on how the light replaces each tiny part of the rough surface. Diffuse reflection is typically used to minimize glare, hot spots and shadows. And this is what the architecture should resort to. Fourth type reflection is known as third type spread reflection, and it is when light is reflected into a cone of light rays from surfaces such as corrugated or etched metal, plastic or glass. The fourth is known as selective reflection, and it is when a colored surface is used so that only certain color wavelengths are reflected as opposed to absorption or transmission. Another view, friends, on reflection. Reflection is a parallel light beam as reflected by a minor reflection area is called regular reflection. If, however, a beam of light strikes a white vast ceiling, the incident light is scattered in all directions. This is known as scattered or diffuse reflection. Between the extremes of these two forms, there are numerous transitional forms, mixed and semi-diffuse reflection. Friends, diffuse reflection is when light is reflected from a rough surface, producing a variety of angles depending on how the light impacts each tiny part of the rough surface. Diffuse reflection is typically used to minimize glare, hot spots, and shadows, as said earlier. Spread reflection is when light is reflected into a cone of light rays from surfaces such as corrugated or etched metal, plastic, or glass. Selective reflection is when color surface is used so that only certain color wavelengths are reflected as opposed to absorbed or transmitted. Friends, we are discussing now surface reflectance of object in an ideal office. As shown in the diagram on right hand side, the ceiling should preferably have 80 to 90% reflectance and walls could be 50% maximum. Office equipment should have a color reflectance of 50% maximum. Window blinds can be 40 to 50% and furniture 25 to 45. The floor may be somewhat darker from reflectance from 25 to 45, this one. Friends, now we are moving on transmission after having discussed the reflection. Transmission occurs when light rays are passed through a material. The type of transmission include direct, diffuse, spread and selective. Direct transmission is when light rays go through the material with no change in their direction or color. Example, clear glass plate. Second, diffuse transmission is when light rays are widely spread, useful when we want to obscure the light source and produce a uniform appearance of light on transmitting surface. Example, inside frosted glass. Spread transmission is when maximum intensity of light rays pass through with little change in direction, producing a glow on the transmitting surface and sense of sparkle. Selective transmission when is when selected color wavelengths are allowed to pass through the material. Example, colored glass. Friends, now we are discussing the material that may be translucent, transparent or opaque. In the tra- transparent, this one, whatever light we throw passes through and all goes out. The transmission is when some of the light is allowed to pass through, and opaque transmission is no light pass through, no light is allowed to pass through. So these three different type of surfaces. Now waiver of material against transmission of light, as I have discussed already. Friends, the diagram on top left provides different type of lighting properties. The first one is transmission ray of light gets through as it is. In reflection, we have already discussed. Refraction is the transmission through a surface, and when the ray which is incident is slightly tilted. In diffraction, one light ray comes and the material is of such a nature that light is diffracted in all directions. Next is adsorption, is the property when the light comes and it is converted into a absorbs wave. Scattering is when light ray come and it is scattered in all directions. This may happen in round surfaces. This chart we have already discussed, and here is shown what happens when we use a transparent material. The light ray is incident. It passes through this material with slightly change in angle, and when it gets out there is further change in angle. So this is known as regular transmission. When translucent material is used, uh, the incident ray like this, inside the translucent material, the ray is slightly deflected, and when it comes out, it is scattered in different directions. The third one is frosted or opaque material. In opaque material, the light is incident, and when passing through the opaque, slight change in the direction, and when it is coming out, it is having a mixed type of transmission here. Friends, now we are discussing grazing or washing. Both are classic concept for wall illumination and facade lighting. So you can see there is a fitting cross-sectional view of fitting, and it is provided so that all light is grazed below. In wall washing, the light fitting is so mounted that it is able to wash through certain surface of the wall. Wall washing illuminates a wall from top to bottom with a uniform light, minimizing shadows and highlighting the wall's color and design without emphasizing texture. In case of wall grazing, it creates a dramatic look by placing light very close to the wall, skimming across the surface to bring out the details in the materials like stone, brick or wood. Both techniques are essential for enhancing the visual appeal of a space, but they serve different purposes and are applied in various contexts. Wall washing is ideal for creating clean, modern look, while wall grazing is perfect for showcasing the texture and depth of the wall. Let me tell you, the grazing is applied to classroom also. Friends, now into selecting lighting fixture. Fixture design can provide high lighting efficiency while also meeting the other lighting objective of the installation. You can use efficient fixture with the appropriate distribution, glare control and visual characteristic for the lowest possible power input. That means energy efficiency. Work with the architectural designer to select fixtures that achieve desired ambient quality while minimizing lighting energy requirements. Also select fixtures that are capable of dimming the light output so that they only supply the light needed to supplement available daylight. Now the direct type of fitting provides illumination in all direction, whereas in indirect type of fitting, the light is reflected back to ceiling, and the light is not allowed to pass through. In indirect and indirect, semi-direct, direct and indirect type of fitting, it goes below as well as above also. So we can pick and choose these fittings accordingly. Friends, according to architecture, a polished surface provides specular reflection, whereas a rough surface spreads provides spread illumination. And third is matte surface, which provide a diffuse illumination. Friends, this diagram shows the law of reflection. Uh, the incident angle is equal to reflected angle, then it is known as normal law of reflection. Now, some media may provide refraction. In refraction, the part of incident ray is partially reflected and partly it is transmitted as refracted ray. Uh, this particular table provides different materials and shows their index of refraction. Diamond is highly refracted. It is having index of refraction equal to 2.419, and there are some other materials which have a value more than 1. The zircon, sodium chloride, polystyrene, ice, tinted glass, crown glass and quad glass. Then some more material are shown here. Benzene, these are all liquids. Benzene, carbon disulfide, carbon tetrachloride, ethyl alcohol, glycerin and water. And this they are giving on the second column gives the value at 20 degree, the index of refraction at 20 degree Celsius. The last I have shown gases at 0 degree Celsius at 1 atmospheric pressure. Air is having roughly equal to 1 and carbon dioxide also something similar. Friends, this diagram shows the transmission. When light passes through an object, it is called transmission. Absorption, reflection, refraction and diffusion. All effect happens. The incident ray is not fully transmitted. Some portion of it is transmitted. Now let us take the case of selective absorption. Instead of completely transmitting light, an object can absorb part of or all light incident, usually by converting it into heat. Many materials absorb some wavelengths while transmitting others, which is called selective absorption. Lambert's law of absorption states that equal thicknesses of a given homogeneous material absorb the same fraction of light. Now, when light strikes a rough surface, friends, the light is reflected or transmitted in many different directions at once, which is called diffusion or scattering. Filtering. A transmissive filter is a material that absorbs some wavelengths and transmits other, while a reflective filter absorbs some wavelengths and reflects other. The amount of light absorbed by a filter depends upon filter's thickness as per light measurement handbook. Frank's glare, excessive contrast or abrupt and large changes in brightness produce the effect of glare. When glare is present, the efficiency of vision is reduced and small detail or subtle changes in the scene cannot be perceived. It may be a direct glare due to light sources within the field of vision. It may be reflective glare due to reflecting from light sources or surfaces of excessive brightness, and it may be wheeling glare where the peripheral field is comparatively very bright. An example of glare sources in daylighting is view of the bright sky through a window or skylight, especially when the surrounding wall or ceiling is comparatively dark or weakly illuminated. Glare can be minimized in this case either by shielding the open sky from direct sight by louvers, external hoods, and deep reveals curtain or other shading devices, or by cross lighting the surrounding to a complete level. A gradual transition of brightness from one portion to other within the field of vision always avoids or minimizes the discomfort from glare. In interior lighting, discomfort glare will be more of a problem than disability glare. The sky luminance over 2000 candela per square meter results in glare. Glare can be limited by using luminaires having proper lamp and their shielding and diffusing arrangements. Friends, a condition of vision in which there is a discomfort, that is fatigue to the eye, or disability is known as glare. It is experienced that if lamps, luminaires, windows, or illuminated windows or illuminated areas are too bright as compared to general brightness in the interior, it causes glare to human eyes, which are then unable to recognize the object which fall under field of vision. Glare can be direct as explained earlier, or can be reflected if observer happens to see the reflection of source of light in a glossy surface. Reflected glare from surfaces below eye level tend to be more troublesome than that from above and therefore must be avoided. Experiments have shown that the source of light or illuminated object having brightness, that is luminance, more than 0.15 candela per square meter is viewed continuously. It causes fatigue to the human eye. Therefore, such objects should be isolated from direct sight to avoid strain due to glare. Even if an object is likely to be viewed only occasionally, it should be screened against direct view if its brightness exceeds the level of 0.3 to 0.5 candela per square meter. It is for this reason that fluorescent tubes are not recommended in residential illumination, as tenants are tempted to use them without any screening or diffuser. Even GLS lamps should not be used without proper shade. Friends, this diagram shows the type of suspended luminaire. The first one is direct type of luminaire. The second one is semi-direct type. You can see some portion of this goes up here and some portion comes to the task. Here it is all, everything is going to task. The third one is semi-indirect. In this case, part of light goes down, whereas most of the light goes up. It is known as semi-indirect type of fitting. This fitting is indirect type in which everything is reflected back to the ceiling. The fifth is general diffuse type of luminaire in which the light goes in all the directions. And this is mixed diffuse type of suspended fitting in which uh, some portion is darkened so that the light is reflected in all direction but not above. So these six type of suspended type fitting are shown here. Friends, this diagram shows all type of downlighters and their polar curve also. This is a downlighter which is known as dispersive reflector. It's having reflecting surface which has a dispersion property. The light is dispersed. In second case, a glass steel diffuser is provided and the light is dispersed. In third case, uh, is known as concentrating spotlight reflector. This has a polar curve of this nature. And fourth shows vertical elliptical reflector, the bedwing type of polar curve. The next is parabolic angular reflector. It has got an angle of throw and the light is scattered. What polar diagram is this? The next one is angular elliptical reflector. It has got an angle and elliptical reflector. The reflecting surface is elliptical, giving a polar curve of this nature. Next, extensive spotlight reflector, and it has a polar curve of this nature. The eighth is intensive spotlight reflector. The ninth one is Kulikan Banflux reflector, having a better reflecting properties. And then a number of reflectors shown as RLM and glass well reflector. These are mounted in exterior portion. Friends, this chart shows different type of reflecting surfaces and their reflection factor. Uh, it is grouped like surface materials, that is new plaster white, aged plaster, distemper, oil paint, cement, etc. Then white enamel type of surfaces, limestone, these are the metallic surfaces, silver, nickel, chromium, aluminium, copper, tin plate, they have got reflectance in of various nature. Then comes the white paper, which has got a good reflectance, 0.8. Gray cement has very poor reflectance value, 0.2 to 0.3. The reflectance value, that means reflectance factor of various color shown from violet, indigo, blue, sky blue, pale blue, green, light green and olive green. They have a varying reflection factor. Friends, this table shows remaining colors and colored surfaces and their reflectance factor. Thank you for peacefully observing my illustrations and presentations.